Welcome to the Doodle podcast. This is episode number 2. My guest for this episode is Dr. Liu Han. He has a PhD in software engineering from Tsinghua University. He's a senior research scientist at the Blockhouse Technology Limited and also at the Oxford-Hainan Blockchain Research Institute, where I was working for 2 years. The episode was recorded in Hainan, but I'm currently in Beijing. I moved here earlier this year. In this conversation, we talk about Ping-Pong, we talk about mobile phones, we talk about software. We also talk about blockchain, which is the technology that underpins cryptocurrencies. If you want to trade cryptocurrencies, you can do that through our sponsor, MEXC, through the link that's in the description below. They accept SEPA payments directly, which is particularly helpful or convenient for people based in Europe. And finally, my podcast episode with Dr. Liu Han.
Okay, awesome. So yeah, thank you so much for taking the time to be here. Mm-hmm. Maybe you can start with talking a little bit about your table tennis experience in Nanjing.
Sure. Thank you, Alex, for the invitation. Very happy to be part of this. And so in terms of my table tennis experience, right? So I actually, it was like almost 25 years ago. So the reason I started to play table tennis at that time is it was because that I was watching this international table tennis tournament. I think it's in 1995 in Tianjin, one of the city near Beijing in China, right? So you know that Chinese players are quite good at table tennis. So, but it doesn't matter at that time because all I have experienced at that time was like very competitive and very fluent, like plays, right? So it very fast and looks like so many skills out there, right? So I was very attracted by the game, by the table tennis. So I started to play with my own like homemade board. So it's very random board, like some paper board from a big box.
How did you make that board?
No,
can you explain how it looks like?
You just cut it from the box, something like this. So it cannot play because I don't have a table for table tennis at my apartment. So what I did at that time is to play with the wall, right? So I hit the ball and it goes back and I hit the ball again. So, and my parents suggested that if you're that interested in table tennis, then probably we could make it an official one, right? So they sent me to this summer camp of table tennis in Nanjing, my hometown, right? So I spent 2 months there, and to be involved in some very part-time like training. But it was at one of those training center in Nanjing. So the training center itself, so a lot of athletes, professional athletes went to that place for their training. But our summer camp is quite like part-time, right? So, but after 2 months, so my coach, my coach later, so she asked me whether me and another guy, whether you guys would like to join this team, even after this summer camp, right? So
like
that
the professional team.
Yeah, like semi-professional team, which means that let's say when I was in the primary school, so joining this semi-professional team means that every day when you finish your school, probably around 3 p.m. right in the afternoon, then you went to the training center to train till like let's say 6 p.m. and then you do it every day, and you will be attending those competitions at your age, of course, but you will be playing for your primary school. Because after
this is primary school.
Yeah, this is a primary school, but actually there was very like real like competition among those primary schools. I didn't know that until I actually start things like this. So though at that time those primary schools are quite concerned, are quite like caring about their performance at this tournament, at these competitions. They care that so much. And so it's not only me but other team members. So we started to play for our own primary school. And when you actually got prizes, right? Like you won like the first prize, second prize. They're actually you're gonna have this big event the next Monday, probably next Monday in your primary school, and they will. The head of the school will like announce the results. Then you will become very famous in your primary school because you're one of the stars, like helping the school to win the medal, win the prizes. Yeah, so so I got like 6 years actually. 6 years basically covers my entire primary school period, right? So then I had to make this decision whether I would like to continue as a semi-professional athlete. But if I continue to do this, I will probably step into the professional phase, right? So in that case, your goal would be like entering the national team someday. Yeah. But on the other hand, your option is to, okay, so I consider table tennis as one of my capability. I like it, but I decided to, continue as a common like student, right? So, but table tennis will be my advantage, my capability here. Yeah, so I choose the second, the path, right? I think the main reason here is because the coach, my coach, so she had the opportunity to go abroad, actually go to Colombia in South American, right? To continue her career, which was good to her, right? So I kind of feel that I don't want to continue this path without her as my coach. So, and honestly, back at that time, so my performance at school was kind of good. So I was not like left behind because of attending this table tennis. So I decided to take the second path. Yes.
Yeah, it's crazy how the right coach, the right teacher can make a huge difference.
Yeah.
Right. In whether it's table tennis like a sport or if it's in school also. Some people they decide to pursue something because they have the right teacher for that.
For sure, that's for sure, because it's not only like teaching you about skills, it's actually, especially at the early stage of a person, right? So basically, if you had a good time with your coach, with your teacher, then it affects you the living status, right? Your mental condition, yeah, all of the kind of things. So you just don't want to change. Yeah, so it's make a big difference. Yeah.
Sure.
Yeah, sure.
Is there any connection between your table tennis experience and then later on when you developed an interest for computers, right? You're a software engineer.
I would say, for me, I would say there is this connection here. Yeah, the reason is because I actually, started to be involved in competition, sometimes very intense competition, at a very early stage of my experience, right? So the benefits of this is to get used to the condition of competition, right? So you know the feeling of competition, because sometimes you cannot avoid competition when you step into the society, when you start your own career, right? But if you're quite used to it, then you might be feeling more comfortable later in your life. So I would say I was kind of quite used to this kind of competition at a very early stage. And being part of this competition means that you might be winning and you might lose, right? So the feeling of loss is never good, but you have to know that you will always lose at some point. So it's no big deal. Yeah, so it happens all the time. It not only happens to you, it happens to anybody else. So it's a very common thing. So I guess this kind of psychology that's what I learned from this kind of experience.
Sure, learning to lose, learning to fail. That's such an important skill.
Sure, and face it, right? Accept that you might lose. Yeah, it is like I think the most important lesson I've learned. Yeah.
How do you think that can be taught? So you learned it from the table tennis, like your experience competing. like if you were to have a child, for example, how would you approach that? The idea of teaching them that sometimes you lose, failure is okay, and that's kind of going through that is a step to something better.
Yeah, I would say that even you're talking to a kid, right, at a very early age. So sometimes you don't have to teach them theories about being comfortable with losses because it's hard to explain, it's hard to convey, right? And in my case, I actually experienced the loss in the very first place, and so I learned these lessons because when I lost, right, and I talked to my coach, I talked to my parents, I talked to my friends, I kind of feel that it was very upset at the very beginning, but it actually not many people are like looking down on you, right? So it's no big deal. So they actually provide this environment to let you to experience the loss, and then let you to know that it makes nothing different because it is quite common. So you kind of learn it one step gradually, and also you will be seeing that many other people that they lost as well. So that what makes you that you're not that unique in this case, right? So it's common, it's acceptable. So basically, they're not trying to. Of course, they talk to you, right? So they say something to you, but I would say the actual learning process is to putting someone maybe in a comfortable environment, in a real environment, which is a real environment means that you don't have you do not enjoy the winning all the time. You feel the loss, right? So give them a real environment and let them know nothing is gonna change, nothing is gonna destroy you, even if you have some bad outcome. Yeah, no problem.
Yeah, that's beautiful. Good times, hard times, never bad times.
Yeah,
so
yeah.
It's a quote from a love letter written by Steve Jobs that you picked out. You put it on your website, said that it's one of your favorite. Does that describe a little bit how you feel?
Yes. I actually, so I learned this sentence from the love letter of Steve Jobs, right? So when I first saw it, I kind of feel that it really hits me at the point, right? So I can totally feel so I have my own interpretation of this kind of sentence, right? So this is pretty real because sometimes when something bad happens on you, right, you might feel upset, but like let's say after 1 month, after 3 months later, right, probably you consider this as a very unique experience. You don't consider it as something you don't want to talk about. You want to delete it from your memory. It's not like that. Sometimes you're willing to speak with it or talk to other people with it. So that means that it's only it might be hard at that time, and it's not something bad because that makes your memory like very unique to somebody else. So I guess that's my understanding on this sentence.
Yeah, for me, one interesting interpretation is whether good times and hard times are separate or whether they come together. Because for me, one of the things I seek out, one of the ways that I found that I feel more alive, I feel like I'm developing, growing, is by putting myself through hard times. So seeking out uncomfortable situations. That's one of the reasons I moved here, is because I can stay close to where my family is, close to where my friends are, in a country where I speak the language.
If you want, right?
Yeah, sure. Or I can come here. I don't speak the language. I'm not familiar with the culture. I don't know anybody when I arrived. Now I have a lot of friends, but I didn't have any when I arrived.
Sure.
And so I felt like this was an opportunity for me to grow. So this is kind of my mindset.
Sure. I totally agree that they're not like independent thing, right? So sometimes they're come with each other and they're like combined, like in a reasonable way. I think it depends on how you view these kind of things, right? So I mean, hard times and good times, they're only your interpretation on specific cases. Maybe different people may have non-consistent views on the same thing, but I guess it tells us you need to understand that they are very common, and they you consider it as hard or as good, but you don't take it in a very negative way, because they are naturally not that bad. So that's probably the key point. Yeah.
Sure. Everything's open to interpretation.
Sure.
So let's talk a little bit about computers.
Sure.
I have a bunch of questions for you. Maybe you can just start by explaining how you got interested in computers, how you first got exposed to them, why you wanted to pursue studying them. Like right now, you study them at university. Now you're working in the industry. Seems like your interest hasn't paused so far. You're still interested, maybe even getting more passionate over time.
Yeah. So my reason of starting to be involved with computer science or maybe software, right, is I think might be quite similar to somebody else, because I used to like playing video games, right? Computer games back at that time is not that advanced, right? It's not that cool. So I remember that my favorite video games was FIFA. Yeah, the football games, right?
Yeah, I love that game as well.
Yeah, I know. you're not only good at playing the games, you're good at playing the actual soccer as well. Yeah, I believe so. So I like that games a lot, right? And so when I was at the point to decide my undergraduate direction major, right? So I picked the software engineering, right? So basically, software engineering is a sub-direction of computer science in general, right? So, but they have a lot of things in common, right? So, but software engineering is more focused on the software subject, right? So basically, it addresses the challenge of how to develop good software. Right. So basically, the development of software is not only about writing code. It's not only about programming. Yeah. So when you have an idea of making a software, you probably will start from writing down some specifications of your software, and then you might be starting to find someone suitable for you to develop that kind of software. So it's like a system process. It's not like coding at the very first minute, right? So basically, you will have a systematic process. So software engineering is about how to designing and enforcing and optimizing this kind of process, maybe different phases, right? So how to generate more like well-specified requirements, how to talk to those people who have the desire to develop a software, to understand their requirements, to understand the use cases, to understand the applications. Yeah, it's not only about interaction thing. It's about what kind of representations, what kind of tools, what kind of methodologies that we can design and use in practice to make this process more efficient. Yeah, things like this. And also, it's about like how to maintain your software even after its official launch, right? It's not like you have deployed your software and it's running and everything's fine. So you will have this operation team, you will have someone to maintain your software. That means when something unexpected occurs, right, you have this solution to understand what's happening here. And even if there is nothing bad happens, you still need some system, some methodology to help the development team, the engineering team, or maybe the service provider, to help them understand what is the condition of your software, of your services. So basically, software engineering is about a systematic process of software development, right? And as I mentioned, it covers a lot with the computer science major. Yeah. So that's basically because I will learn a lot of theories and practical methodologies from computer science as well, because these two majors are basically tightly mixing with each other, right? So I would say they have something in common, but they have their own uniqueness as well. But the very first, at the very beginning, the reason is quite simple. So I was quite interested in doing something related to computers. So basically, software engineering is definitely one of the offer on the table. Yeah.
You mentioned at the beginning that maybe the story, how you got interested, is quite similar to other people. Do you think video games is the most common way for people to start getting involved in computer science? Like now you have a lot of colleagues, you've met a lot of other people in the industry. Do most of them start with video games? Is that how they get interested?
Yeah. I mean, it's hard to confirm and imagine, but I would say let's say at my age, right? Many of our friends and people I know, right? So if they are like very interested in playing video games, there might be the chance that they're quite open to step into industries related to computer or related to computer science. Yeah. So, but things may change, right? So I'm not sure where, because nowadays we have a lot of very, fancy technologies, right? And video games is not a very hard thing to reach, right? And we have all sorts of applications, mobile applications, and we have all sorts of very interesting devices and new types of computation happening everywhere. So I would say video games might not be the only one of the only forms of attraction these days, because some kids might get attracted by some other forms of very cool technology. That kind of thing might be their reason to step in the industry. But for me, I would say video games is quite an important factor.
Sure. Mm-hmm. So yeah, for everyone who, I think a lot of parents sometimes they're concerned about their child's video game usage. Mm-hmm. For all those parents out there, know that maybe your kid is going to want to work in the computer science industry later as a result of their video game experience.
Sure. That happens a lot, actually.
On a separate note, so you're fluent in English and Mandarin, and as a software engineer, you also know some programming languages, which is the language that we use to communicate with computers. What is some of the similarities or differences in the languages you use to communicate with humans, natural languages, English, Mandarin, and the languages you use to communicate with computers?
Yeah, I think this is a very interesting topic to discuss, right? Because we have those experts like linguistics, right? So I believe they're like expert in these domains. But for me, that apparently the natural language has a lot of things in common with the programming language, because they are languages. They are languages, so they will have syntax. They will have semantics, right? Things like this. That means that commonly when you speak English or Chinese, so there is this underlying structure you are actually using, but you don't feel it every minute, every second. But there is this structure here. You're gonna be using these nouns, verbs, different forms of constructs in your language, right? And it is actually the same case with programming languages, because if you have some experience of writing code, you know that there is this keywords, right? So sometimes these keywords and different structures. Let's say if you would like to specify a sequence structure, that you do one thing, one action, and followed by another action, right? And you would also have this selection structure that based on one specific condition, whether you might go this way or the other way, right? And you will also have repetition structure, that you do something a couple of times until some condition is met, or unsatisfied, right? So these kind of structures are like quite similar to what we have in natural languages, right? So I think in a very general sense, they are quite similar to each other.
Are there any key differences?
Yeah, for sure. The key differences here, I would say, for me, I would say the level of ambiguity, right? Okay, so when you speak natural language, no matter whether you're speaking English or Chinese or maybe other types of languages, so if you make mistakes, that's basically no problem, right? Because the other guy you will have a very good chance to understand you well.
Yeah, from the context.
Yeah, from the context, and you don't have a very standard way to speak English, right? Even if you're speaking in a wrong way, that doesn't affect that much, right?
Sure. From my experience learning Chinese, like I will often say something. My teachers will often say, "I understand what you're saying, but we don't say it in this way."
Oh yeah. That's pretty much the exact case, right? So, but you probably have the experience that sometimes some people may get the exact opposite meaning of your, because you're like, for example, making a mistake here, right? Or sometimes someone else may get quite confused about what you are saying, right? Because he or she may have different possibilities to interpret your words, your sentences, right? And they are quite uncertain about that. So this is about the ambiguity, right? And undefined interpretations, what we call it undefined semantics or behavior, right, of your language, which means that you say something, but the whole system does not define. If you say something like this, what does that mean? The whole system does not define, right? So natural language does not have too many things like this. But in programming, in the case of programming language, sometimes we have the exact specification of the language, which means that you can only speak the language. When I say speak, actually probably you're programming or maybe you're coding. When you speak this kind of programming language, you have a certain way, a limited way, a required way to do that. If you're not doing this in an expected way, then probably the programming language system won't allow you to do so. So the way they reject you is by triggering some errors or not, or things like this, right? And one of the other instances here is that programming languages are commonly avoiding ambiguity as much as possible, because if you have ambiguity in a programming language, then the computers might get quite confused to execute your language, to enforce it, because the computer is not aware the real meaning of your programs, of your language. It might be a disaster because for different computers, they might have inconsistent execution of the same programs, of the same programming languages. Then that might be a disaster, because the computers cannot interact with each other, because they don't have the same, they don't have the common knowledge. I would say that would be one of the major difference here.
Yeah, I have to say that's a powerful combination of languages that you speak. English, probably the most spoken language worldwide, with Mandarin also, and then programming languages, you can communicate with computers. So it's a powerful combination.
Yeah, so that will be a lot of conversations in my case.
Yeah. Everyone I know, besides babies and my grandfather, the only exceptions, have a smartphone. They carry their smartphone with them pretty much everywhere they go. In China, where we're in China for people listening who don't know.
Cool.
There's over 1 billion smartphone users.
Really?
Yeah.
Okay.
Which is crazy.
Yeah.
What are the implications of everyone carrying these mini computers in their pocket? Is there a right or a wrong way to use them?
I mean, from the technology perspective, right? I would say that it's basically an involvement of technology, right? So we now have a very powerful computation capability with such as small devices, right? Small devices means that you need to be equipped with very powerful hardware, and like processors, devices, right? Inside this kind of size, right? So now it has been achieved, right? And it's widely spread. So that will be extreme technology improvement from my perspective, yeah. And so everyone is holding a smartphone. So everyone has the computational interface to each other, to any other kinds of interfaces. So those kind of interfaces might not be held by some real people. It might be held with some machines, with some artificial intelligence, with some services. So you don't know, right? But since we have the capability to hold this kind of smartphone and to use it as an interface to others, right? So the world is become, more connected than any time ever in the history, right? So I would say this is definitely a technology improvement, right? But we would have other types of issues with this kind of interoperability or connection on our hands, right? Because let's say, for instance, when you have this kind of interoperability, that means that we're in China right now, someone from like thousands of kilometers away might have the capability to reach your device, and through your device into other devices. So if you think this from a very negative perspective, so this kind of connection, this kind of interoperability might create a natural network for something bad to propagate, to broadcast, right? So I would say if you consider this as a technology, then it's probably an improvement, something to celebrate. But if you consider it as a social artifact, or maybe as something like in a larger scale, right? You probably need more things, not only technology improvement, but maybe other like laws, like the solutions to govern, right? And even if some like social policies that not only China but maybe the globe, if they are willing to stick to one like social like policies or maybe interaction standards, that will be better, because the technology will be used in a more like in a proper way, I would say, yeah. So it's hard to say it's wrong and right, it's correct or incorrect. I would say when you consider this as not only a technology, then it becomes a more complicated problem.
Sure.
Yeah. So I would say you have to define the right and wrong in specific applications.
Yeah.
Yeah.
This is also one of the reasons I think it's so important to talk to people like you, because you have an understanding of what a smartphone is beyond what the average person is. You know, a lot of people, they'll use their smartphone, but they don't really understand what's happening underneath it. How does the software work? These hardware components that you mentioned, a lot of people will never have heard of them.
Sure.
And so they're using these devices without really thinking about what it means. And so there's no really right or wrong. Like, we can make that up for ourselves, what it means to be right and what it means to be wrong.
Sure.
But I think there is a need to educate, especially children now at a very young age. They're getting smartphones, and a lot of people, they don't really know what that means. They don't know how to use it.
Yeah, sure. I think this kind of issue should, as you suggested, should be like part of the early education process, right? So yeah, to like very young kids to understand that if you are using this technology in some way, what does that really mean, right, to you, to the society? I think because the environment has changed a lot than like probably like 20 years ago. So this technology should be maybe part of the education, I would say.
Sure. How would you just on a very higher level, how would you approach that educational problem? So if you were to help create that, right now there's no education, right, related to technology and smartphone usage for children at school, because smartphones are so new, and the educational system, it usually lags behind, right? It takes some time for schools to catch up with new technology. If you were going to help to teach some kids at school about what a smartphone is, what they can do with it, what they maybe shouldn't do with it, how do you approach that?
I would say that smartphone is only an instance of computers in general, right? So basically, computers will give you the capability to compute over kind of data, right? So I would say one important lesson for nowadays kids is to help them understand the importance, the significance of data itself. And so I would let them understand that the data is everywhere nowadays, and let them know that what kind of good things that data can contribute, what kind of negative effects data might introduce. So basically treat data as your friend. So use your friend in a positive way. So I would say I'm probably my focus would not be on the smartphone itself. Would be data for them, because many of the actual good or bad things are actually closely related to the way people manipulate their data, or maybe somebody else's data, right? So I would say this kind of thing is, I will let them know that this is an entry point for your manipulation of data, for your processing of data. So you need to be need to be careful when you are dealing with data. So this is very important, right? So I think that's the ideas I would like to convey with them.
Yeah, be thoughtful of how you manipulate data and where your data goes. A lot of people don't think about that. Like, using your smartphone gives a lot of people access to your data.
Yes.
And that's, people are becoming slightly more aware of it today, but still, I think,
like not like far from the right, the sure, ideal word.
Far from maybe what you understand as someone who studied it. I'm curious also, how has studying computer science changed the way that you interact with computers, so with your smartphone and things like that? Do you think if you hadn't studied it, would you be acting differently? How is that knowledge you've acquired?
Probably yeah. But that's also true that even if let's say I have some background, right? So probably I don't like see everything in a different way, right? Maybe I will see everything like as somebody else will do, right? But I think you're right, because when you have this background, this knowledge, you might have a different understanding on the levels of innovations behind, right? For example, if you are not knowledgeable of computer science or not, maybe you consider the artificial intelligence, you may consider the innovation of smartphones, the robots, in a very straightforward way. Means that they look cool, right? They look fancy, right? So that's also that's very possible, right? But if you have further knowledge of those kind of things, you might, for me, I will often think about where is the challenge, the technical challenge here, right? Because you know that they are probably using some kind of technologies, right? And you would like to know, so what is the challenge here? So whether this is really a cool thing, so this is happening on an application level or at an infrastructure level, because that means totally different thing to us, right? So I would like to know, okay, so this is cool, but this is this is a cool app that somebody else may have the chance to develop a same one or similar one, or this is very powerful technology. It's not easy for ordinary people to copy or extend, because it is very powerful technology, because the core highlights, the core innovation is quite challenging. So it might be, it makes me feel better if I am able to figure out things like this. If not, I might be like getting confused at some point. Yeah.
Sure. I think that probably studying this kind of things, at least for me, it makes me more aware of how powerful these tools are. And like the saying goes, with great power comes great responsibility. I think a lot of people don't realize when they're holding a smartphone what they're holding, like how powerful these computers are. And so they don't, they're maybe not thoughtful of the extent to which they should be responsible for the way that they use it.
Yeah, I think one instance here, one example here is that, let's say if you have this Android smartphone, right? Android smartphone. So you I don't know whether you heard about one concept of like rooting your smartphone. That means that to help you get the highest privilege, the highest access permission for your phone, right? So commonly, if you search that kind of thing on the internet, right? So you probably have some tools to help you automatically acquire the root, permission of your phone, right? So it becomes, when you have the root permission, you might be able to, let's say, equipping your smartphone with a lot of new functionalities, like install some apps that you cannot install before, right? So things like this. So this rooting process becomes a very, sometimes it's useful, sometimes it's very cool functionality for some people, for some users. Not for everyone, but because it's kind of complicated sometimes. But if you have some tool to do that, it will become convenient, right? So, but if you have more knowledge about this rooting process, you probably would know that the rooting process is actually a hacking process of your smartphone. So basically, you are using some services from, let's say, a safe hacker. Yeah. So because the design of the smartphone is to avoid you getting, all this kind of weird permissions from your side, because you're a common user, you don't have to use that kind of rights, right? Even if you would like to have them, but it's not the design specification of the smartphone, right? So if you're trying to do so, you have to break the original design, like let's say the original protection of your phone. So it's basically a hacking process, but the hacking will be not that difficult for nowadays. But sometimes it becomes harder and harder, but it's possible sometimes. So basically, when you have this kind of services, sometimes you don't know what was happening inside. But actually, if you're like from the computer science major, you probably would know that actually you're using others' services to hack your own phone, right? But there might be chances you're using a malicious services. Then they help you unlock your phone, but at the same time they will inject something inside your phone so that let's say your data will be collected in an unexpected way. That might be possible, but you do the math. You measure the risk here, right? But if you know that, then nothing happens. Maybe your data has been collected for a long while, but maybe you're quite comfortable with that. Yeah.
What about you've lived in China and the US also. Mm-hmm. Huawei is banned from selling their phones in the US, right? What do you think about that? Is that justified from your perspective? The way you understand you talked about the safety specifications that the phone manufacturers will put into the phone. Mm-hmm. I think a lot of people have never thought about the things you just talked about, like routing, hacking into their phone to create special privileges and accesses. Mm-hmm. But so yeah, each phone manufacturer, the way I understand it, they'll create their own safety specifications. Mm-hmm. And the US is concerned with Huawei. Is that something that's justified?
Yes. I would say that this kind of situation is probably one of the instances I mentioned in a large scale. I would say this situation, the better way we understand this situation is from the technical perspective, because it might not be only the technical thing, right? But from the technical part, it becomes clearer. Yeah, because the real conflict here is that so apparently the U.S. Will have a lot of regulations. As you mentioned, that the safety, security, security specifications, maybe privacy specifications, requirements, standards, all types of things, right? And so they have these regulations. They're not sure whether Huawei's protects are gonna consistent with these kind of regulations. So the only way to do this at this moment is to ask Huawei to provide their information about all kinds of information of Huawei and their services, their devices, their smartphones to the US, so that they would be able to audit whether you're actually violating these regulations or not. But apparently Huawei are very reluctant to do so, because they're quite sensitive confidential information, right? Like source code and configuration and maybe some other types of metadata, right? So basically it's not possible for Huawei to provide those kind of information to the US. So the US would be able to audit everything, right? So the real conflicts here. So how do you establish the trust without revealing
trust? It's written on your shirt.
Yes. How do you establish the trust without revealing the secrets? So basically, it becomes a technology problem if you consider this in this way, right? Of course, there are many other factors, but I would say my focus would be here. Yeah. So this is something not easy to do so. Yeah.
Right. There was a point in time when you didn't know anything about computers. Now you're a senior research scientist in the industry. How do you explain that process of going from not knowing anything to becoming an expert in something? And is there any wisdom from your experience that you think other people can benefit from if they're trying to go from not knowing anything to becoming an expert?
I would say the motivating power would be like passion, would be curiosity, right? So you have to really like those kind of stuff. You really need to have this curiosity. So that basically drives you to a step forward, right?
For passion and curiosity, is that something that you need to find what you're curious about? You need to find what you're passionate about, or can you learn to become passionate about something? So maybe someone who's not so passionate about computers, now they can learn to become passionate about computers.
I would say you have to pick probably a combination of both solutions here, right? So you can experience as much as possible. So that gives you the chance to find your passion and your curiosity, and you still need to learn to grow your curiosity, grow your passion through like systematic plans. Let's say, so when I was doing the academic research of computer science of the related stuff, right? So sometimes your passion comes from a level of satisfaction. Like, let's say if you fail one time and two times all the time, it's probably hard for you to be that passionate about this kind of thing. You may think about, maybe I'm not the right guy for this direction. Maybe I should change, right? So basically you need to look at a very specific problem or maybe task. And you need to find a group of people that is, let's say, experienced, right? And you would be able to learn important lessons from those people. And you probably would have a higher chance of succeeding at the very early stage. By success, I mean that you may have some positive feedback. You may like publish a paper. You may win some prize. You may have set up some computer science experiments successfully and get the programs running as expected, and you get the results, right? And you would be able to have the passion to share it with others. You would like to let somebody else to know that you're doing these kind of things. Maybe they are common on your projects or on your stuff, and you feel even more passionate about this. So don't look at some gigantic topic at the very first place, right? Otherwise, it will be hard for you to progress. Then you don't feel the satisfaction. Then it becomes harder for you to continue your passion. Yeah, so step by step, I would suggest. Yeah.
What's kind of the steps that you took to build up to where you are now?
So I think I can use my previous research experience, right? So when I graduate, so from the undergraduate university, right? So I have this thesis as my undergraduate thesis. It's not very big. It's not that deep, frankly, right? So then I started my PhD period, right? So the first project I did at that time was actually continue my undergraduate thesis, because I was quite familiar with those kind of details, those kind of things, and so my job at that time was to convert those kind of thesis and projects into one project as my very first PhD project. So that will not be that difficult, right? But during this process, I have the chances to learn how to do the research in a professional way, right? What kind of processes you will be experiencing, what kind of outcomes you're trying to deliver, right? And because I have some background, so that might not be that difficult for me to progress at the very first place. Of course, but in my case, that's not like fluent as expected, because I remember that I submit a paper based on the undergraduate thesis project, and it got rejected 3 times. 3 times means probably 1 year and a half.
What does that mean? So you took your undergraduate paper and you wanted to submit it and then pursue that for your PhD?
No, I have this undergraduate project, right? So I continue it at my early years of my PhD. When I started my PhD, I still expanding this project, and I decided to write a paper about this project and submit it to an academic conference, but it got rejected 3 times. So that means probably 1 year and a half. Yeah. So it's not fluent, but during this journey, it's not like I'm not progressing at all. I actually have some positive feedback to keep my passion running, right? But it's not. But the major goal at that time was not achieved. It's just because your paper has not been accepted. So that was something unexpected. But still, you will be able to progress. I guess it's important. Yeah.
Awesome. In 2018, you got an Ethereum Foundation scholarship for DevCon 4. I'm bringing this up because I think it's a good time. You just mentioned that you got rejected a few times.
Oh, yeah.
So I think it's nice to follow up with some successes.
Okay, thank you.
Last year, you got awarded the ICDC Best Demo Paper 2020. This year, you got first place at the Rebase Hackathon, sponsored by the Ethereum Foundation. Is there an achievement you're particularly proud of in your career so far? And also, what are your aspirations for moving forward? What are you hoping to contribute?
Yeah, sure. I would say the things you mentioned are like very positive results for me. Not only me, but some other like co-workers, right? So my colleagues. So basically, they are very positive outcomes. But at this moment, I don't think they're like very. So their impact has to be further amplified if we do more work in the future, right? So my aspiration at this moment, because I'm now in the blockchain industry, so my aspiration now is to use blockchain as a underlying infrastructure or maybe tool. So my general aspiration would be build up this, to establish this highly connected ecosystem for the innovators, right? For maybe technology people, for maybe governments, yeah, for financial institutions, things like this. So I think the connectivity, the interoperability would be the best, the biggest potential for a blockchain. So
can you explain what that means, interoperability, in the context of what you're explaining now?
Yes. So interoperability basically means that different participants in an organization or maybe network would be able to understand and compute with each other using different data, different rules, and different computation processes from different parties, right? So basically, you don't have to own all the data by yourself. You don't have to know every detail of somebody else methods, somebody else processes, because you don't have the rights to do so. Even if you're trying to know, they will not let you know, because they will feel uncomfortable about this, right? So if you don't have a good level of interoperability, basically you can do nothing, because the way computers run and the way programs are executed are basically based on data and processes and computation processes. If you don't own them, then you might not be able to create innovations on top of them, right?
Right. You said if there's no interoperability, you can do nothing.
You can do very limited things.
Okay.
Yeah.
I think a lot of people feel like they can do a lot with their computers and their smartphones. So there is some level of interoperability now, but you're saying that if we can improve it, enhance it, we can do even more.
Oh yeah, sure. What I mean here is that you can nowadays actually we're experiencing interoperability. It's just not in a very obvious way, right? So, but the interoperability is there, right? For example, you can use one Google account to log into many other applications. So you can consider this kind of things as an instance of interoperability. That gives you the capability to use one identity to interface to many other web applications, and make sure that they are consistent with each other, right? So that's probably one instance, but we can have more than that, yeah. So I would say that interoperability is something that that is very important in this direction, and my aspiration is also about this as well. Yeah.
No, awesome. Mm-hmm. In the blockchain industry, which you're currently working in, there's a lot of trendy terminology, like Metaverse, NFTs, Web 3.0, interoperability, decentralization. Can you paint a picture for people who perhaps they don't understand how everything fits together? Can you maybe explain where we are right now and maybe where we're going also?
Okay. So maybe I can start with decentralization, right? So basically, decentralization describes a different way against centralization, right? So it's basically a different way to organize and maintain a network, or maybe an organization. Let's say a network, right? So you may heard of the word distributed, right? So I would say both decentralized services network or centralized network nowadays are basically all distributed networks, which means that you don't have only one machine or one node in this network. You basically have a lot of nodes in the network. So the major difference here is whether there is one leading node in the network, or maybe several leading nodes in the network that schedules the whole network or not. Or like every node in the network is kind of equal to each other, right? So when you have some central nodes in the network, the advantages here might be quite efficient, because everything is synchronized through those kind of leading nodes, right? It's probably like in the army, right? You have generals, and generals post the orders, and the others to follow the orders, right? It becomes very efficient in some way, right? But there are many other use cases where it is very hard to find these generals, find these leading nodes, because other participants in the network are not willing to admit that someone is the leading nodes. They would think about that I could be the leading nodes if if you have to pick someone, right? So what I mean here is there might be cases where a decentralized network is more aligned with the situation, right? Apparently, decentralized networks are actually making a trade-off, right? So because there are no leading nodes in the network, then efficiency might be a thing to consider, right? But the good part is that because there is no such leading nodes or central nodes, right? So everyone will replicate the state of the network independently. Then it becomes more stable, more secure in some way, because it's hard to manipulate the network. Because in the previous case, if the leading nodes are bad, then we kind of sucked, right? But here, one or two nodes become bad will not affect the fact that there is a majority of nodes in this network that are still reliably replicating the whole network. So it's kind of hard to say something invalid in this network. So that gives you a very different experience in setting up level applications. But I would say decentralization is the idea of organizing a network in a different way. And again, both decentralized network and centralized network are probably distributed these days, right?
Sure. So it's like if you had a small community, maybe a few hundred people, you could have this. It's distributed because there's not one person, there's many, and either everyone votes and everyone's vote is equal whenever you want to make a decision. So anyone can come up with an idea. I come up with an idea. Everyone votes, or we have one or two leaders and they make the decisions, right? So that would be the distributed versus the decentralized.
Yeah. Quite similar to ideas like this. And
I'm just trying to put it in like kind of simple terminology that anyone could understand.
Sure. Yeah. That would be a very valid interpretation of this kind of terminology, right? Web3 is Web3 basically is talking about web applications, the involvement of web applications, right? So
for a lot of people, I think they're probably thinking right now, Web3, what happened to Web 1, Web 2, you know?
Yeah. So I haven't heard about Web 1, Web 2, so now it's Web 3, right? Yeah, but actually what we are currently using are probably categorizing to the Web 2 section, right? So Web 2, so the terminology of Web 2 is quite related to what we have described, the decentralization concept. So basically, currently the web service are provided by some central service providers like big companies, right? Google, Facebook, Twitter, yeah, things like this. And the major difference here between Web 3 and Web 2 would be the real ownership of your data and of your, let's say, account or maybe your information, right? Because Web 3, because there's no standard explanation to this problem, as far as I see it, I see Web 3 as a combination of centralized and decentralized web services, which means that at some point you will order or you will follow the framework controlled by some central companies. But at some other areas, you might be quite independent in those services, which means that in those areas, you can have the access to real ownership. Let's say if you have some kind of asset, you really have the ownership of that asset because you will have some cryptography, let's say, guarantee that only yourself would be able to use it, to access it, even if the service, let's say the web service, are actually storing your asset or storing your data. They're only storing your data. They would not have the access to it without your permission. That's the guarantee from the technology, right? So this is pretty much different from what you are if you're dealing with a centralized service, because you basically trust that the central service provider will be making good custody of your data and assets in a very reliable way. But if they don't, you never know, right? Maybe you know someday, but you cannot be sure about that they are doing the good thing all the time. But again, it's not like Web3 is trying to eliminate all centralized services, because that will be very hard to achieve, because centralized services, they provide a lot of very good user experience at this moment, and it's hard to imagine that Google, Facebook, and these all big players are gonna become decentralized like in one day, right?
Yeah. For someone listening, maybe a question that's relevant for them is, currently with Web 2.0, you use Facebook, they own your data, they sell it to advertisers, that's how they make their money. Instagram, they take your data, they sell it to advertisers. In Web 3.0, will people be able to use these services, and instead of the service owning their data and selling it, they can then choose, okay, I want to sell my data, and then they get paid to watch advertisements?
Yeah, sure. So because if the in a Web3 application, if the specific piece of data is monetized, then it becomes an asset of you.
Sure.
Yeah. Then you can make the decision. Yeah. You can still let them to process your data anyway, and you can still choose not to have any benefits, simply because if they are dealing with your data, they would be able to offer a bigger capability here to offer you a better services, right? Sure. Because you cannot do that because you don't have the technology and resources.
We get to sign up for free, use it for free, but we pay with by giving them our data.
Yeah, sure. But you can make the decision. Yeah, you can. Maybe nothing changed, but actually a lot of things changed behind, because you have the option to do one thing or the other. Yeah, and so basically this is Web3, right? And it's closely related to the concept of NFT, right? Non-fungible token, right? So basically, I see NFT as a tokenization method to wrap up something, either from the physical world or from the virtual digital world, right? So I see it as a solution to tokenize something so that they will become standard and they will be circulated in a more flexible way, right? So basically you can tokenize let's say nowadays you can tokenize a digital art, right? Paintings, very famous paintings, right? You can tokenize some very interesting, let's say, logos, things like this.
How do you tokenize something that's physical? Like if it's a JPEG or just some image online, you can very easily convert that. You put it through some system, it gives you a token ID. What about if I want to tokenize, like you said, a digital piece of, not a digital, I mean an actual piece of artwork?
Yeah, that will be much more difficult, because you have to deliver the guarantee that this kind of connection is always there, right? You will not like change the physical thing to another one and still keep the token there, right? So this basically requires more than a simple tokenization process, right? So, but if you are in a digital world, you basically the simplest way to do this is to, like, for example, hash something, right? So you know that if something is got hashed, then you would have the information to decide whether it is changed or not.
Yeah, just for people listening who don't know what hashing is a one-way function. So you take an input, you put it in, you get an output. but you cannot go backwards from the output. You cannot get back to the
yeah,
input.
it's very hard to go get back. And if the raw information is changed for, let's say, only 1 bit, then the hash will be totally different, right? So basically, you cannot provide something not as you claimed before.
Yeah, it's a way of authenticating things. So if someone claims that this is the hash of this piece of this document,
yeah,
a lot of people use it to check the authenticity of a document, right? If you want to download a software,
sure,
you can hash the software, compare the hash to what they claim the hash is, and if it's the same, then you know it's the actual piece of software. If it's different, you know that maybe someone's changed something, someone's tampered with it.
Yeah, exactly. Yeah, and so then it might be easier, right? So the tokenization becomes easier than if you are dealing with physical items, right? And basically, if everyone is comfortable with the concept of NFT, right, and everyone is trying to accept to interface NFT with their own services and business, then NFT becomes a very standard way to circulate assets, so circulate important data, to circulate different kinds of rights, right, things like this. So I would say NFT itself is only a name, a concept, right? So basically, this is a very popular way to wrap up data together, right? But the real problem here is whether you're wrapping up meaningful data or not. So as long as I said, we have both angels and evils at the same time, right? Currently, because you have some very meaningful tokens that make sense, but still you will see a lot of tokens that basically are not that are not making any sense at the same time. So I think the real question here is about the whether you're making sense with your whether you are exploiting this kind of non-fungibility in a meaningful way, right? And metaverse would be the hardest topic for me to explain at this moment, because it actually covers, so there's no like one consensus against metaverse at this moment. I would say one of the common knowledge of metaverse is that we all know that it covers not only blockchain, it covers a lot of like virtual reality, artificial intelligence, and Internet of Things, all kinds of technologies together. So basically, the core idea is actually coming from a very popular novel, like a couple of years, like I forgot that, maybe it's 20 or 30 years ago, right? And so currently, when we talk about metaverse, we're basically talking about a digital connection, a digital world that connects physical items, and map them into the digital world. Basically, this kind of digital mapping here. But as we all know, that is not easy to enforce the mapping in a secure way, in a reliable way, right? Because when something happens in the physical world, you have to make it align with the digital world so that we'll have almost similar or same effects. That would be extremely hard, right? So basically, in current days, I have been seeing a lot of people talking about metaverse, but actually they're talking about NFT, things like that. That's possible. I would say NFT might be the tool to be designed as an implementation or as a building block of the metaverse, if the real metaverse is really there, right? So NFT might be a building block of this, but does not equal to metaverse, right? I would say this. So there is a very large imagination space for metaverse at these days. I would say it's very hard to define and explain. Yeah, in very simple words. Yeah, but the real point here is about the digital mapping from the digital world and the physical world. Yeah.
Cool. Is Bitcoin going to outlive us? Will Bitcoin exist when you and me exist no more?
I don't know. I don't know. One thing I'm quite confident about Bitcoin is that I'm pretty sure that Bitcoin is gonna last for a very long period of time. Yeah, the reason is because the past 10 years basically is stress testing Bitcoin in a very hard way, right? And as we know that no like catastrophes happen on Bitcoin, which means that it's a very reliable system. It's a very reliable network, and the concept of Bitcoin, I mean, how this concept of Bitcoin is gonna align with some other types of like cryptocurrencies or maybe currencies in general, right? It's become the main challenge here, right? So apparently a lot of but different countries are using different strategies against Bitcoin. So I would say this is something like inevitable. So, but I would technically Bitcoin is quite reliable based on its current stress testing outcome, right? So I don't think it's gonna disappear in a short term, right? And but the large scale application will still will be depending on how the countries, how the governments, and how the industries view about Bitcoin themselves, right? Because you know that Tesla was accepting Bitcoin as the form of payment, right? But things changed later, right? So you can imagine if a lot of businesses are actually involving Bitcoin as one type of payment, that will be a total different thing.
Yes or no? Is it gonna outlive us? Will Bitcoin still be here when we're gone? Yes or no?
Probably.
I think so too.
Yeah. Probably because it's imaginable, right? Because you can imagine a world that all the Bitcoin nodes are actually maintained by some algorithms, by machines. So these machines can, to some point can like last for a very long time, right? Unless some very bad things happen on Earth, right? So I would say probably, yeah. Mm-hmm.
What are you working on at the moment?
So as I said, that I'm basically working in the blockchain industry, right? So I'm kind of creating our own blockchains at this moment, and the goal, the design goal of this blockchain is to equip this blockchain as with strong interoperability. Yeah, as I mentioned earlier, and the interoperability here means that you will be able to use this blockchain to interface to not only decentralized systems like other blockchains, but also centralized applications. Yeah, so because currently almost all the blockchains we talk about are basically talking about the cryptocurrencies and tokens themselves. So those kind of things are like originating from the blockchain itself. So they're kind of not connecting to the outside world that much, right? So that is basically the space that we're trying to cover.
Okay.
Yeah. Mm-hmm.
Well, you mentioned also that the way you got introduced to blockchain is through smart contracts.
Yes.
Also, your most cited co-authored paper on Google Scholar is about re-entrancy bugs in smart contracts.
Yes.
How, when you learned about smart contracts, a lot of people, they perhaps don't know what they are. But the idea is that it's a contract that's enforceable through code. So right now we have contracts that are enforceable through law. So I'll sign a labor contract with the company. I'll sign a contract with the apartment here that I will pay them a certain amount every month. And if I don't, then there's lawyers, there's a court, there's regulations that will prevent me from or like enforce penalties. For smart contracts, it's enforceable through code. Right, which is pretty revolutionary.
Yeah.
When you first found out about that, what was your initial impression?
Yeah. As you mentioned, that basically you can consider smart contracts as a digital form of contract compared to like physical contracts, right? You have different rules and consequences and future later actions if you satisfy or not satisfy some kind of rules, right? So basically a contract between several parties. You can consider it as this way because it acts very similar to this way on blockchain, right? Like manipulating and processing different assets from different parties. But you can also consider as general programs on blockchain, right? Basically, programs are a form of contract in some way because you have the logic of the program. The logic basically is trying to enforce some actions based on specific conditions. So that's basically quite similar to contracts. So if you think smart contracts as a form of programs on blockchain, then you will have a lot of views. You can borrow a lot of views from the traditional programs, right? Because programs, when I first knew smart contracts, I kind of get this kind of understanding because I consider them more as programs. Then if you have programs that you need to make sure the programs are like reliable, secure, and you also have the possibility to let's say optimize the programs to make it run faster, right? Things like this. So my starting point about smart contracts is about, as you mentioned, is about the security, right? How to guarantee the security of the smart contract because it is smart contracts is on a blockchain and they are manipulating assets, cryptocurrencies, right? If they are insecure, actually it's gonna be very bad because you might have your cryptocurrencies like stolen by others and they will you cannot get them back because these are like immutable because you're on the blockchain. You have to follow the general rules, right? And these real things happen in practice. So my starting point would be like verifying the security of smart contracts. Yes, and I would say this is still a very important topic these days. Yeah, but it stays as an unresolved problems. So I would be very happy to continue research and let's say product development on this direction. Yeah, I think it's still very important these days. Yes.
From table tennis to computers to marriage, you're married, right?
Mm-hmm, mm-hmm.
What is the meaning of all this? What's the meaning of life?
Meaning of life, I think meaning of life is to experience and understand, right? I mean, for me, the most exciting experience of life is to understand different perspectives. Maybe you're like maybe you're with somebody else. For me, like my parents, my wife, right? I mean, understanding of each other is I think is quite important for me in my life because when you have the chance, like for you as well, right? You have the chance to travel all over the world. Yeah. And then you might be seeing very different ways and styles of living, right? And you might be meeting very different people. And you don't have to judge or decide whether this is better or this is worse, right? You have to know that they have a totally different views of the world. They have different ways of living. And for me, the good part of this understanding is that if you have this kind of understanding, then you go back to your life, your own life. Then if you have some problems, right? If you have some bad, like very hard situations, right? You would be able to like search the database and then you load one of those memories, one of these views from somebody else, right? From your memory database, right? And then you would be able to know that, okay, so this is nothing big deal, right? Because someone else on the other corner of the earth, so they are kind of, it's pretty common for them because they have views on, different views on this, maybe a similar issue, right? So then you're more peaceful with yourself, with your life. So I really like to like travel a lot, but the travel is not only about like taking photos, but of course I take photos, but it's not only about taking photos and food or something. These are all really good experience, but they give me the chance to know different people. Yeah, because they will tell me the stories I will never hear in my own environment because they are like quite different, right? So I think that's my if I have this kind of chances, that will be the luck for me, and I will be understanding the meaning like this. Yeah.
Yeah, a lot of people recently they're maybe frustrated or disappointed with the fact that they can't travel, right? There's COVID, things like this. One of the solutions that I found for myself is that I can travel with my mind by reading books.
Oh yeah.
When I read a book, I enter into new worlds. I meet new people, and yeah, it helps me to relate also to other people and experience. And not only can I travel to other places that exist now, but I can travel to the past. I can travel to the future with sci-fi. So yeah, for me, that's one of my ways of traveling around the world.
I see.
On that note, do you have any book recommendations or any resources that you think people can benefit from?
Yeah. Honestly, I might not be the perfect guy to recommend books because I'm not kind of that the book reading people, right? But what I can provide here is that if let's say if you're trying to dig into computer science or things like this, then maybe you need to start from the most classical resources in these settings. For example, we have this Dragon book. Dragon book is about compilers of is about compilation and compilers. It basically tells you how your programs are gonna be converted into executable code of your machine.
Right. It's from like the code that you might look at when you type to binary, like zeros and ones.
Sure.
Right?
Sure. Yeah. And so this is pretty much the most difficult part and most hardcore part of computer science, right? And this is a very famous book, like legendary book in this direction. And so if you have the peace, you have the patience to really understand this kind of book, right? Then you might be able to get those very essence of this kind of science. Then later in your other parts of experience, you will like constantly had this feeling. What feeling? So the feeling of that, okay, so this is actually related, or this is actually similar to the core concepts I've learned from the Dragon book. This is all like fundamentally the same, but different implementations or different settings. That's all. But like naturally they are the same, or they are similar in some way. So that will gives you one general or unified understanding on the science, on the major itself, but gives you more capability to innovate in the future because you know that, because the real innovation comes from that your deep understanding, right? You understand that what kind of problem you are trying to solve, and you know that there is this fundamental solution and theory to this. All you need to do is to customize your theory to this specific problem settings. Then you might be having more potential in this kind of innovation. So I would say if you're studying computer science, you probably have already read about the Dragon book. But if you don't, maybe you can revisit, or you maybe start reading the Dragon book. Like you don't have to finish it in 1 month or in 1 week. You can maybe have a year or maybe even 1 year, but make sure that you find the beauty of this book. Yeah.
Yeah, I think what you said about the innovation is really true also, because if you just are working at a surface level, then all you can do is copy other people. But when you have the profound understanding, you understand the fundamentals, then you can take those fundamentals and maybe go in a different direction from what people did before.
Sure, yeah. And then tricky part is that sometimes you don't think you're actually copying somebody else, but actually you are copying somebody else, but you cannot tell. That's the real problem, because you don't have a very systematic or comprehensive understanding on this kind of stuff. You think you're creating something new and very dope, right? But you're not. Yeah. So, but you need to have the right evaluation system to judge, right?
Yeah. If someone's listening to this and they want to reach out to you, how can they do that? You have a website, right?
Oh yeah, I have this personal homepage. Basically, you can have a check out of this website, and I have emails.
Yeah.
Right.
What's your website? How can people find it?
Yeah. So the website is njaliu.github.io. Right. So basically, it's a GitHub page. Yeah. And so you will have my email address there. Yeah. Okay. I think that's probably the most straightforward way to reach, because I check my email every single day, every half an hour. So it's gonna be like super convenient.
Awesome.
Yeah.
Awesome.
Mm-hmm.
Yesterday at the office, you weren't there, but we had a Thanksgiving party.
Oh yeah.
And they put out some cards that you can write on. So I picked up this thank you card, and I wrote you a thank you card. Thank you
Cool.
for.
Thank you so much, Alex. Yeah.
Thank you.
Thank you for your time. Yeah.
I hope you enjoyed the episode. If you did, don't forget to like and subscribe. Also, check out our sponsor, MEXC, through the affiliate link below. If you want to reach out to me or to Dr. Liu Han, you can do that using the links that are in the description as well. Take care.